Okay, in this video we're going to talk about parametric equations, which are found in section 10.6. So first of all, let's talk about what we're used to doing, which are rectangular equations. So here's an example one, y equals x plus 3. So basically, y is a function of x. And if there are no restrictions on there, like in this case, we'll know that the domain is all real numbers for which the equation is defined. So in this case, the domain would be all real numbers. And the very first way that you learn how to graph things is you pick values for x and you substitute them into the equation. So for example, I could pick an x value, substitute that into the equation, and so y equals -5 plus 3. That would work out to be -2. And then that's an ordered pair, -5, comma, -2, and then you graph it. All right, so that's a visual of one solution of that equation. And of course, you could, randomly put some other numbers in there. If you use -1 for x, then you'd have +2 for y. All right, or if you put in +2 for x, then you would get +5 for y. All right, and in this case, we know this one is going to give us a line, since our equation is a linear equation, and then we can connect all the points. So every single point on here would represent an ordered pair solution of the equation. So like I said, this is a rectangular equation. Now, let's look at a parametric equation. All right, parametric equations, you would usually have two of them in 2 dimensions. And what they are is they're written in terms of a third variable, which is called the parameter. So for example, x equals t minus 3 and y equals -2t. This is a set of parametric equations, and t is the parameter. So each equation is written in terms of t. Now for this one, I tried to just pick a very simple domain. T could equal -2, -1, 0, 1, and 2, just to keep it easy. And the way you would work with any one value of t, let's say if t is equal to -2, you would substitute it into each equation separately. So we would take t equals -2 and put it into the equation for x first. So x would equal -2 minus 3, and that would work out to be -5. And then you would take -2 and put it into the equation for y. So y would equal -2 times -2, and that would give you 4. All right, so what we've now come up with is the ordered pair. Remember, they're x and then they're y. What we're graphing is going to be -5, 4. So over here, we'll have a point, and that's on the graph. All right, so that is a solution of these parametric equations. And then if you try a different t value, then you have to go back and put them in individually again. All right, so we'll just keep it simple here. So then you would put in -1. So x equals -1 minus 3, that would be -4. And -2 times -1. I erased the wrong thing a minute ago. And that would give you +2. And then we would come up with this point here, -4, 2. All right. If you put in 0, get the idea here. 0 minus 3 would be -3. -2 times 0 would be 0. Have a point here. If you put in 1, you'll have -2 for x and -2 for y. And if you put in +2 for t, you'll have -1 and -4. All right. Now, these wouldn't be connected since I just made t be those values. If I had done -2 to positive 2, then it would be this segment here. Okay, and then these have an orientation to them. As your parameter is increasing, that's the order that the points are going. So this is the smallest value of the parameter, -2. So this is the first point. Then this is the next larger, so that's the next point, next point, next point. So this actually has an orientation or a direction to it. So the basic idea with parametric equations is each equation is a function of the third variable. So in this case, x and y are each a function of t. And sometimes you'll see it written like this: x equals f of t and y equals g of t. Now,